In 2022, a vending machine-sized spacecraft traveling at 14,000 miles per hour deliberately slammed into an asteroid. The impact was a monumental success, proving humanity could change the course of a celestial object. Now, a second nation is preparing to demonstrate its own capability to do the same, aiming for an even more ambitious integrated test. If successful, China will become the second country after the United States capable of altering an asteroid's orbit. This isn't just about playing cosmic billiards. This is about planetary defense. We live in a solar system filled with billions of asteroids, ancient remnants from its formation. While most are harmless, some are classified as near-Earth objects, with orbits that bring them close to our planet. A significant impact could have catastrophic consequences. China's upcoming mission, announced by the chief designer of its lunar exploration program, Wu Ren, represents a major step in building a global defense network against such threats. This test is designed to build on the lessons from NASA's groundbreaking DART mission and develop a comprehensive system that includes detection, warning, and response.
And this is a story not about a single mission, but about the birth of a global strategy. To understand it, we'll first break down the ingenious concept that NASA's DART mission demonstrated. Then, we'll uncover the details of the ambitious Chinese test that takes this idea to a whole new level. And finally, we'll look at the big picture. What does it mean for our planet when such an incredible technology is no longer in the hands of just one nation? Let's start with the precedent. The Double Asteroid Redirection Test, or DART, was NASA's proof-of-concept mission. Its target was Dimorphos, a small moonlet orbiting a larger asteroid named Didymos, millions of miles from Earth. The key insight from DART was that hitting an asteroid with a projectile could be surprisingly effective.
The DART spacecraft, launched in November 2021, was essentially a smart battering ram. After a 10-month journey, it autonomously navigated to its target, and on September 26, 2022, it impacted Dimorphos head-on. The result was a stunning success, far exceeding expectations. The impact altered Dimorphos's orbit around Didymos by 32 minutes, a huge change from the minimum success benchmark of just 73 seconds. Data from telescopes and a small companion satellite called LYSIA-Cube, which was deployed before impact, showed that the recoil from the tons of rock and debris blasted into space, the ejecta, contributed significantly to the orbital change. This confirmed that the kinetic impactor technique is a viable method for planetary defense. DART proved the fundamental physics works.
Now, China is preparing its own planetary defense test. While the launch date has been mentioned as occurring as early as this year, other projections place it around 2027 or 2030. The mission will target a different near-Earth asteroid. One potential candidate that has been identified is named 2015 XF261. The core objective is similar to DART's, to change the trajectory of an asteroid through a high-speed collision. China's plan, however, introduces a significant evolution in methodology. Instead of relying on a separate later mission for post-impact analysis, like DART's European Space Agency partner mission, Hera, the Chinese plan involves launching an impactor and an observer spacecraft together. The observer craft will arrive at the target asteroid first, conducting detailed surveys for 3 to 6 months to map its size, shape, and orbit with high precision. This pre-impact study is a crucial step.
Then, the second spacecraft, the impactor, will collide with the asteroid. The observer, watching from a safe distance, will record the entire event in real time. It will analyze the impact crater, the cloud of ejected debris, and measure the immediate change in the asteroid's path. This integrated approach provides a complete before and after picture from a single mission, a significant leap in efficiency and data collection. The goal is to nudge the asteroid's course by just 3 to 5 centimeters. While that sounds tiny,
Over a period of 3 months, that small deflection would cause the asteroid's path to deviate by over 1,000 kilometers. This mission is part of a much larger strategy. Chief designer Wu Wei-ren has stated that China is developing a complete planetary defense architecture. This system includes not only deflection technology, but also a sophisticated network for detecting and tracking near-Earth objects. Ground-based facilities, like the China Compound Eye Radar Array, are being built to provide early warnings. This integrated system aims to identify threats, issue alerts, and then have a tested, ready-to-go solution to deal with them.
So, what does this new mission really change? For planetary defense theory, it provides a second vital data point. One successful test is a breakthrough. A second test, with a different methodology and a different type of asteroid, validates the entire strategy. It will help scientists refine their models of how different asteroids react to kinetic impacts, which is crucial for planning a response to a real threat. For future missions, China's 2-in-1 approach could become the new standard, offering a more comprehensive and cost-effective way to conduct these critical tests. In terms of global safety, having a second nation with proven asteroid deflection capability enhances our collective security. China has also expressed a willingness to cooperate internationally and share data, which is vital for a threat that affects the entire planet.
Looking ahead, the immediate horizon involves the launch and execution of this test mission. Its success will be a major milestone for China's space program and for global planetary defense. It will provide invaluable data on the mechanics of asteroid deflection. Following this, the European Space Agency's Hera mission, set to launch in late 2024, will arrive at the DART impact site in 2026. Hera will conduct a detailed crime scene investigation, analyzing the long-term effects of the DART impact on Dimorphos. Together, these missions will give us a much clearer picture of how to protect Earth.
Further into the future, the development of planetary defense will likely accelerate. We can expect more sophisticated detection systems, perhaps space-based telescopes dedicated to finding potentially hazardous asteroids. Scientists also hypothesize about other deflection methods beyond kinetic impactors, such as gravity tractors or laser ablation, although these are still in the conceptual stage. One model suggests that a network of rapid response interceptors could be placed in orbit, ready to be deployed on short notice. The ultimate goal is to move from reactive testing to a proactive, layered, and globally coordinated defense system, ensuring we are prepared for whatever the universe throws at us.
The successful deflection of Dimorphos by NASA's DART mission was humanity's first step in learning to defend itself from a cosmic threat. China's upcoming mission is the critical second step, building on that knowledge with a more advanced, integrated approach. By validating these technologies and fostering international cooperation, we are slowly but surely building a shield for our planet. Up next, we'll explore another facet of our cosmic neighborhood, the ambitious international plans to build permanent bases on the Moon, and what challenges lie ahead.